Now, recursive formulas are just a different way to write the rules for sequencing. The explicit rules are the ones that we already know. Like for an arithmetic sequence, we know that to find the nth term explicitly, we just take the first term plus the common difference times n minus 1. And if we just want one specific term of a geometric sequence, we take the first term times the common ratio to the nth minus 1th power. We like explicit rules because it helps us find each specific individual term. But a recursive rule is something that's a little bit more natural for us because how a recursive rule is written is in two parts. First part would tell you what the first number is. So we would say that, A1 is 7. And then it would tell you how to get the next one based on what the previous one was. So what it would say is to find the nth term, we would take the n minus 1th term, we'd take the last term, and add 3 to it. So together what that would tell you is that we start at 7, and then my next term is going to be 7 plus 3, or 10. And the next term after that is 10 plus 3, or 13, and so on. So this is just another way to write our sequence as far as the formula goes. The downside to it is that we have to start somewhere and just keep going. I can't just find the 10th term real quick, because in order to find the 10th term, I need to know what the 9th term is. So in order to know what the 9th term is, I need to know what the 8th term is. I need to go all the way back and start at the first term and work my way up. Whereas with the explicit rules, we can pinpoint one specific term and find that 10th term immediately. So let's write the recursive formula for this sequence. Remember, there's two parts. The first part is tell us where we start, and we're starting here at 3. And now how do I get to the next one? If you notice, we're adding 10 each time. So to find the nth term, I'm going to take the one previous to it, the n minus 1th term, and I'm just going to add 10. And there's my recursive formula. How about if we're multiplying? When we go from 16 to 40, that's multiplying by 2.5. And from 40 to 100, that's multiplying by 2.5. And from 100 to 250, that's multiplying by 2.5. So start with your first term, which here is 16. And then how do we get to the next term? Well, we take the previous term and just multiply it by 2.5. That's it. Some sequences aren't as straightforward as that. Maybe you stare at this number for a little bit, or this sequence for a little bit. We've talked about this one in class. Do you remember how it's made? How we get 2 is by adding 1 and 2 together. How we get 1 and 1 together. How we get 3 is by adding 1 and 2 together. How we get 5 is by adding 2 and 3 together. How we get 8 is by adding 5 and 3 together. So what's the next term going to be? Well, 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. And so on. Okay? In this case, we didn't just start with one number. We do have a first number, but we can't get to the next one yet. We actually need to define our first two numbers as both of them being 1. Then, to get to the third number, we would take the 1 right before it and the 1 2 spaces back and add them together. So this is how we'd write the recursive formula for this one. This is a special kind of a sequence called the Fibonacci sequence. You might have heard of this one before. A famous Italian mathematician who created this sequence, and there's a lot of good math in it that I'm not really going to get into now. But it'd be a good idea to Google them and see what you come up with. I also want to talk about iterate functions just a little bit, and all that is the repeated composition of function. Now, what that means is, let's say we have a function f of x is equal to negative 3x plus 1. We're going to let our initial value be 2. So what I'm going to do is plug 2 in. And all we do is plug it into our function, simplify it, and get an answer. Then, in order to find the next iteration, I'm going to take that -5 and plug it into the same equation. And here we'll get 16. So the third iteration is going to be f of 16. And so on. So all that an iterated function is taking a number, plugging it in, take the result, plug it in, take the result, plug it in. And that's about all I want to say about iterate functions. If you want something to Google that involves iterate functions, look up fractals. This is one of the coolest parts of math. I really love it. And you're going to see some cool stuff there.